Hello everyone and welcome back. Previously, we investigated whether blockchains are immutable or not. We researched that there are some times when we actually want to delete or erase some data from the blockchain. That might be because the data is no longer required or it takes a lot amount of storage, or it might be some other concerns by the governments or some authorities, maybe some organizations that need the erasure or deletion of specific data from the blockchain. Now we are converging towards a different side of blockchain to survey that whether the convergence of machine learning and blockchain is possible or not, and if yes, then how. We all know that machine learning and blockchain are the leading technologies of the information era. Both of these technologies work on data, and we have seen quite few examples in the past that machine learning is also somehow converging into using blockchain combinedly, right? So here is a paper that I got, and let me go through the abstract first and tell you what is this paper all about. But before that, let me just brief you that in this paper, there are a lot many techniques, and I would say a lot many ideas that show how machine learning and blockchain can be used together as one entity and be helpful to each other. So the abstract says that machine learning has been persuasively researched nowadays, and it has been applied in many aspects of real life. Nevertheless, issues of model and data still accompany the development of machine learning. So, as machine learning has been in the power for so many years, there are some problems that are still undefined and they don't have any solution yet. And for instance, the training of traditional machine learning model is limited to access of data sets, which is generally proprietary. So there may be companies that have lots and lots of data sets, and that data set is not accessible to all. Maybe because they feared some privacy issues, maybe some other issues. They don't want to share that information or data set with everyone. They don't want to make it open source and somehow, right? And similarly, the published machine learning models may soon be out of date without updation of a new data and continuous training. So that's true that if machine learning models that purely run on data, if that data is not updated time and again, the machine learning model will soon be out of date and won't be able to keep up with the new updated data, right? Malicious data contributors may also upload wrongly labeled data that leads to undesirable training results. And the abuse of private data and data leakage also exist. With utilization of blockchain, an emerging and swiftly developing technology, these problems can be efficiently solved. So, from the abstract, what we get is that there are mainly three problems. The first one is that if the dataset does not get updated regularly, the machine learning model will soon be out of date. Second is the data might be proprietary and it would be limited to access would be limited to some of the people, not to everyone. And third is that there might be some issues with data privacy, data leakage, or might be some malicious data contributors that wrongly label the data that will actually change how a machine learning model gets trained, right? So here is just a brief about from this paper. Next is we'll take an in-depth approach and see what the introduction is about. So from the marking, published machine learning models may soon be out of date without continuous training. Malicious data contributors may lead to undesirable training results, and abuse of private data and data leakage still exists, etc. These are some of the problems we face. Limited access to data sets, right? We all know that most of the data sets are open source, but still there are some and lot many data sets that are owned by some of the organizations that might not be open source. So there is limited access to the data sets. Training of machine learning models requires large amount of data sets, which might or might not be true, because now there are many machine learning models that do not require so much of data to be trained on. However, most data sets are proprietary, which means the ones who want to train machine learning model on certain problems have limited access to the necessary data sets. This must be true in case of, say, healthcare data set. Not everyone has the access to healthcare data set because it is very private, and it is necessary that you don't provide that basic critical healthcare data set to each and everyone. Next is out of date models. So if the data is out of date, the model won't be able to keep up, and of course the model will get out of date. When a machine learning model is trained and published, it will soon become out of date without continuous training on a new data set, right? That's true because the model would lack some kind of generalization after some time. Next is malicious contributors and bad data. Even if the updatable data is available to machine learning model, the data contributors may not be trustworthy. So here is the third problem, that the data contributors who are contributing the data might not be providing the right data. They might be labeling a car as a cat, right? We don't know. But our machine learning model also does not know. It will learn from the labels only. Abuse of private data and data leakage. In traditional machine learning training, it is difficult to track the users and their ability of certain data. Therefore, data contributors may fear of abuse of their private data or data leakage. That means they might be reluctant of giving away their data sets or access to their data sets, right? So, an increasing number of researchers have been paying attention to convergence of machine learning and blockchain and solving problems exist in traditional ML model training. Training of traditional ML models is limited to access of data sets, which is generally proprietary. To address this concern, a framework of sharing updatable model on blockchain can be used to incentivize data contributors to machine learning model and help continuous training. So what this means is we can set up a framework that is sharing updatable model on blockchain. So what happens is that whosoever contributes some data to the model or the ML model gets some incentive for that data contribution that helps in continuous training of the machine learning model and keeping it up to date. So beside that incentives mechanism can be also reduced negative influence of malicious data contributors by detaining the deposit of them. So if the person is giving malicious data to our blockchain or to our data set, if he or she is supplying some bad data, then what we can do is we can also detain the deposit of them. We can just get some amount deducted from their blockchain or their deposit to ensure data privacy and avoid data abuse. So for that, there is another concept of federated learning. If you are well versed with the concept of federated learning, you might know that federated learning is all about data privacy. So there was a paper by Google some time ago that was based on federated learning, and I'll just give you a gist of that. That what happens in federated learning is that the data remains in your device. The model is gets to your device, it is set up in your device. The model gets the data from, say, Instagram or so what. It gets the data from your mobile. The model gets trained on your device, and just the weights are sent back so that the main model can be trained upon. So what happens is the main data from your mobile or your device does not leave your device. Hence, your data is private and your privacy is maintained. That's the basic logic of federated learning. To protect your privacy of data while allowing collaborative machine learning training, right? Although federated learning enables contributors to share federated models learned over decentralized parties, it still faces some problems of malicious server. So for that, we will be using some blockchain-based incentive systems. One of that is called Deep Chain, and we'll understand it a bit later. Apart from that, there is a contract called Danku contract. That's a classical protocol built on top of Ethereum blockchain for evaluating and exchanging machine learning model. Similarly, there are many marketplaces also that use decentralized AI and blockchain. So you can make sure that the privacy is maintained as well as you get the authentic data for your machine learning models. And meanwhile, if you have the data, you can also collaborate on those platforms. Right. So next is here is a brief introduction of machine learning. I don't think that might be required, but for just a brief of it, here is a basic machine learning. Here's a basic neural network. So what happens is you have three layers. First is the input layer from which the data goes in. The mid one is called the hidden layer, and the third one is the output layer, right, from which you get the outputs. So these all three layers are interconnected with each other. So every node is connected to the every other node. There are three types of layers: input, hidden, and output, as we have already seen. The nodes on the input layer are used for input the data to train the model. The biases and the weights, that is the green lines you can see, these represent the biases and the weights of the models that are adjusted to increase the model performance. Then the hidden layer acts as like a black box to figure out the relationship between the input and the input data and the output labels. And finally, the output layer that gives us the result of the trained model. After training step, the accuracy of model is validated by using a testing data, and once it's trained, the neural network model can be applied to perform on a new data set. So that's the basic of a machine learning model, right? Next is that what's a brief introduction of a blockchain. So there's a paper, it's actually called white paper for Bitcoin. It's called a peer-to-peer electronic cash system that was introduced by Satoshi Nakamoto in January 2009. So it is just a basic introduction to the blockchain technology. Feel free to just hop in and give it a go. As an emerging technology, blockchain functions with the following properties. So blockchain, as we all know, is decentralized. So there is no middleman, no third party. The privacy protection is the main aim for blockchain. It's immutable. The information cannot be modified. And if it's modified, it stays in the list. So you know when the information was modified, by whom it was modified, and from which original information it was modified. Then the traceability is good. You can ideally track from where the data came and where it go, to whom, to next, who first gave in the data on the blockchain. Everything is available on the blockchain, right? So here is a basic schema of blockchain and how these blocks look like. So each of the block contains the hash of the preceding block, so the chain is maintained. Now, to the original part that we were thinking of is the application. So, application of converging machine learning with blockchain protocol that incentivizes data sharing. So, what happens is machine learning models require data, and blockchain has lots and lots of data that we all know. So what happens is you incentivize data sharing. That is, that if someone or a person or an entity provides some suitable data that is good enough, that is labeled perfectly, that is a good data, then it gets some incentive, maybe some reward in some kind, right? So that's the basic need, that you provide good data and you get incentivized for that. So it helps to reduce the fear of data abuse or data leakage, and the data contributors also get rewarded for providing reliable data. At the same time, marketplace also encourages model sharing. So we have a marketplace where model sharing is also easy. So you have the data. Now, if you put it on the blockchain, you can actually use that platform for model sharing as well as working together as a one entity, right? Protocol that incentivizes data sharing. So we have learned about sharing updatable model before, that is sum on blockchain. So here is the image, you'll understand with that better, is that there is a collaborative trainer, there is an entity, this person you can see, XY is the data that he or she is providing, and there's a function called add data. So once they provide the data to the model, the incentive mechanism gets triggered, and the data handler then gets the data and incentivizes and checks whether the data is authentic, it's good data or not. And if it is passed that it's a good data, it's a reliable data, then the person who has given that data gets some incentive or some rewards, gets rewarded, and the updated data goes to the model and the model gets updated and it predicts on the new data. So that's the basic of sharing updatable model. Next is blockchain gamification. To reduce the barrier of entry, no financial incentives such as points, badges, and can be awarded to reliable data contributors. Right. Next is reward, refund, and take self-assessment. So there will be, if you're getting rewards for good data, you will be you'll face some penalties or a punishment for providing bad data as well, right? So if you're providing bad data, you'll have to face some reductions in your points or something like that. Next is blockchain powered FL system, that is Federated Learning System for privacy and all. So idea is data privacy protection, that is to share model and data model instead of revealing the actual data. So raw data owned by contributors are stored locally by themselves, hence there is no need of fearing of data leakage. So what we are doing is, here in the image you can see each of the local entities, these the circle ones you can see in reds and blues, those are the IoT devices that provide data that goes directly to the local model on which the model gets trained. Then the local model gives just the trained biases and the weights to the blockchain that is uploaded there, not the original data from the IoT devices. So that data does not leave the main device, the IoT device, the data does not leave that, hence the data is safe and is not leaked. So that's how the blockchain whole thing works. So every local model can just provide the gradients and the parameters and the weights that you used rather than providing the original data. So to understand better, we can look into figure 4, the architecture of secure data sharing scheme. Proposed system consists of two modules, permission blockchain module and the FL module. Permission blockchain establishes a secure connection among all end IoT devices. So the blockchain has connection with all the IoT devices through encrypted records, right? It manages the accessibility of data and records retrieval transaction, data sharing actions and other related data, and all sharing events of data instead of recording raw data. So it does not take in the raw data. Instead, it just keeps a record of the transactions made and anything related to data, but not the raw data. Next is the FL module that shares the federated data model learned over decentralized multiple parties. An original created consensus is a proof of training quality which decreases the computing cost as well as communication resources. Another concept that comes in handy is called deep chain. It's another way of ensuring data privacy while creating a protocol that incentivizes data sharing. So, according to the developers of Deep Chain, the distributed, secure, and fair deep learning framework solves many security problems neglected in federated learning and provides value-driven incentive mechanism based on blockchain to force the participant to behave correctly. So it's basically the simple kind of a process where you get incentivized for sharing good and reliable data. The developers made the following contributions. The deep chain proposed with an incentive mechanism encourages joint participation in deep learning model, training and sharing of obtained local gradients. So basically, this incentive mechanism encourages that you work jointly for training models as well as you share your local gradients that you get from training your models. Both privacy and local gradients and the auditability of training process are guaranteed. Next is marketplace that encourages model sharing. Danku contract is one of the classic protocols that is built on top of Ethereum blockchain, and it's basically a marketplace for evaluating and exchanging machine learning models. You can also say it as a platform for supply and demand. So the demander or the organizer who has data set brings out a question and the supplier or the submitter submits their well-trained machine learning model to solve this problem. And in the final stage, the one whose model performed best and ranks the highest is actually the one who gets the payout. So let me just go through these figures on the right hand side that will help you understand much more better. So take for an example, say Bob is the person who has the data set and who has the problem, right? So he sends a hashed data group, some hashes, and gets random training indexes in return. And then when he sees that there are some submitters or people who are interested to solve his problem, he reveals the training data set. That's the initial stage. Then say there are three people, Alice, Daniel, and Carol. So they get the training data from Bob and they submit their solutions. So that's the submission stage, right? Then Bob reveals the testing data set to all these three participants or the submitters. And then in the final stage, he evaluates the submission of all three. So when the testing data set is revealed, they test their models on that and they submit their evaluation, and finally Bob gets to know which submission did the best. That is, which machine learning model was best trained for his data set to solve the particular problem he had. So in the evaluation stage, he finds out that one of the persons, said Daniel, he is the best submitter. So Daniel would be paid out. So let's take in case that there might be a case that all three of the submitters did not submit a good solution. So in that case, the money or the payout goes back to Bob, who was the organizer or the demander. So that's the whole supply and demand model for the Denku contract. Next is another one that is kind of similar to Denku, but before that, let's just go through this one, DINMO. So it's an architecture, a more completed marketplace for both model and data sharing conducted on the convergence of decentralized AI and blockchain. So what happens in this one is that new machine learning model on a marketplace, a user can upload that, or it can enhance the existing machine learning model by submitting their data set. So it's like a two-way. You can give your data set and your new one data set, and you can train it on the existing machine learning model, or you can add or upload a new machine learning model to this marketplace. Right, so what was the architecture in general is the user is able to select the model that best fits the data he or she submits by using a validation mechanism in the marketplace. The next is that if data set submitted by the user helps the machine learning model perform better, a reward will be paid to the user according to the incentive mechanism. Right. So in both the cases, you will get some incentive. That is, if you upload a good machine learning model that best fits and the data that it's already available on the blockchain, then you get some incentive if it's passed through the validation mechanism. And the second one is that if you have a data set that helps the existing machine learning model to perform better, then also you get some incentive. Right. So here in 12th figure, you will see some Hawk overview that uses this protocol. Let me just go through this Hawk one before that. So the main issue that Hawk focuses on is transactional privacy. So that is actually neglected in many of the systems, that all transactions are exposed clearly on a blockchain. So we know that blockchain is immutable, and one of the main advantages of blockchain was that all the transactions are open. You can see the transactions happening, you can see who paid whom and where did the information travel. But this is also has some disadvantage, that the transaction has no privacy. So we need that in some of the portions. Right. So in reference, the author developed this decentralized smart contract system that does not store financial transactions in clear on the blockchain, thus retaining transactional privacy from public view. So a smart contract system that does not store the financial transaction is actually privacy, because you don't want people to know how much bitcoins or how much currency do you have just by looking at your financial transactions, right? You want to keep your bank account safe, you want to keep your transactions safe, right? So moving on to that, we have some limitations to the research and further research as well. So first is the incentive mechanism. What is the limitations to that? Is that it may not be feasible to judge the validity of the data solely on decline of the lost function. So it may be that we say that this submission is the best one, but sometimes that submission or that high accuracy might be because of overfitting. The model might be overfitting the data set. So it is not actually a proof that it's a good data submission or a good machine learning model submission. So incentive mechanism is flawed over there. So here are some improvements that they've suggested, like the form of loss function can be adjusted. For instance, we can control the step that a lost function declines so that overfitting may be avoided as an error of model diminishes. Some other incentive engines that consider change in accuracy when computing the reward of the contributors are also one of the parts in the improvements. Next is privacy. As we've already talked about data privacy and transactional privacy, they proposed some future work that is done to not submit data directly to the smart contract by using complex models. And contributors can just submit encoded inputs or submit inputs to the hidden model, so which hides behind an API and not necessarily public. Also, blockchain technology can also be used for standardizing and tracking utilization of data. So you can actually see who is using your data and where your data is actually transferred to. Right. Apart from that, one more thing that potential is cost control. So we don't really have the control over gas fees. So we don't know that the transaction or storage of data set, the transaction you make, or training of a model, how much gas fees it would take. So there, whenever you're running something on a blockchain, that's the limitation of running a smart contract, that you have to take in control the gas fees as well. Right. Next is model diversification. So restricting to storage spaces. We always have restricted storage spaces. So it might not be possible. So, to have large amounts of data sets that's there, or large amounts of models that are huge in size, and especially the unsupervised models, to solve more complicated issues. And finally, for the conclusion, they say that we've given introduction to ML and blockchain. Then we looked into detailed applications and innovations, and some of the the limitations of blockchain and machine learning coming together. But all in all, this is a promising future to development of the fields of machine learning and blockchain. And I feel as an ML enthusiast, I would say that this is very interesting when it comes to data privacy, especially in the era where data is so big and data is so important to us, and as is data privacy. So I think if we can make best use of blockchains for data privacy, and also make use of machine learning models at the same time, it would actually bring a big change in the privacy and the data security or the cyber security industry. So with this, we have completed one more paper. I hope this paper was interesting to you. That's not much of technical thing, but it gives you an overview of what's going in research for blockchain and machine learning together. And if you are a machine learning enthusiast as me, I think it would give you more horizons for you to explore, and you can implement your machine learning trainings and models to this part of the technology as well. So I hope you enjoyed this video, and if you have any doubts, do drop in the comment section. And thank you for being with us, and keep learning.